So in this problem here, we have block P with a mass of 2 kilograms connected to block Q, right, of mass 3 kilograms by a light inextensible string. Both blocks are on a plane inclined at an angle of 30 degrees to the horizontal. So let's first draw this incline. So we have an incline that looks like this, right? And we have block P, which is right here. And then we have block Q, which is here. So we are told that block P is 2 kilograms and block Q is 3 kilograms. And they are connected together by an inextensible string, right? And we are also told that the slope is 30 degrees, right? Okay, fine. And then block Q is pulled by a constant force of 40 newtons at an angle of 25 degrees to the incline. So we are told that block Q is pulled by a force that is 40 newtons at an angle of 25 degrees, right? So now we know that the objects are moving up, right? Upwards. So now block P moves on a rough section of AB of the incline, while block Q moves on a frictionless section of BC on the incline. So we are told that block P, so let's say this is A, up to here it's B. So it means that there is friction here all the way up to this point. And then from B to C, there is no friction here, right? So block P moves at a friction surface, right? And then the other one at a frictionless surface, right? So another thing is the friction we are told to be 2.5 newtons, right? Okay, fine. So now that we have analyzed the question, or the statement rather, let's look at the questions that follow. So now the question says that calculate the magnitude of acceleration of block P while block P is moving on section AB, right? So the most important thing here is to first identify the free body diagrams of both blocks. So the free body diagram for block Q is as follows. So as you can see, block Q, so this will be block Q, right? And then this is the force applied, which is equals to 40 newtons. So this is the angle of 25 degrees, right? So now another force that is acting on block Q is the force of gravity, and we also have the tension, right? So now that we know this, we need to find the F net of this block here. Remember that if we are going to say this is the force of gravity, this will be the force that is perpendicular, right? Remember that since we have this, we're also going to have the force parallel. So meaning that it will also be somewhere here. It will also be somewhere here. The force parallel, right? So we have 1, 2, 3, 4 forces that are acting plus the normal, that is perpendicular to the surface, right? So these are the forces that are acting on block Q, right? But what's important is the force parallel, is the tension, and the force applied, but in a horizontal direction. So which means we need to include this force applied but in a horizontal direction. That's what's important. So the first thing we're going to do here is to first identify the force parallel, which is this one here. So we know very well that since here it's 30 degrees, that means here it's going to be 30 degrees too. So we're going to draw a line which is parallel to this one, meaning that this is the force parallel, right? So if you use this 30 degrees, it's going to be opposite. So it's going to be sine 30 degrees is equals to opposite, which is F parallel, divided by hypotenuse, which is F of G. So F parallel is equals to F of G multiplied by sine of 30 degrees. So we cross multiplied. So this is the value of the force parallel, right? So now we are done finding this force parallel. The tension we're not given, so it's unknown. Let's find the force that is applied but in horizontal direction. So if you look at this triangle here and you say this is the force applied but in a horizontal direction, so we can use cos because it's adjacent to this triangle here, which has a right angle. So you can say cos of 25 degrees is equals to, what's the adjacent side? The force that is applied but in a horizontal direction divided by the force applied. Then we're going to do your cross multiplication. The force applied in a horizontal direction is equals to the force applied multiplied by cos of 25 degrees, right? So the force applied in a horizontal direction is equals to the force applied, which is 40 newtons. So it's going to be 40 cos of 25 degrees. So now we have this force here, which is the force applied but in horizontal direction, and we have the force applied and we don't have the tension, which is not a problem. So that's what we need for block Q. So meaning that the F net of block Q is equals to, so because it's moving upwards, it means that the force applied in a horizontal direction is dominant compared to the other forces. So minus the tension minus the force parallel is going to be equals to MA, right? So the force applied but in a horizontal direction, it's this one here. So it's going to be 40 cos 25 degrees minus the tension minus the force parallel. Where is the force parallel? It's this one here. We found it. So it's F of G sine of 30 degrees is equals to the mass. The mass of block Q, we know very well that is 3. So it's going to be 3 kilograms multiplied by acceleration. All right. So now we can just put our equation in a more or less of a standard form. So remember that this is F net, right? So it's equals to this here. All of this equals to 3A. 40 multiplied by cos of 25 minus T minus F of G sine of 30 is equals to 3A. So this is the formula. So let's write it in a more clear manner. So let's transpose this one that side. I'm going to have minus T minus F of G sine of 30 degrees is equals to 3A minus 40 cos 25 degrees. We transpose this here. We're going to have minus T is equals to 3A minus 40 cos 25 degrees plus F of G sine 30 degrees, right? So this is going to be our equation 1 that we got for block Q, right? So now we're going to identify equation 2 from block P. So now that we found the equation 1 for block Q, let's find equation 2 for block P, right? So the first thing we're going to do is we're going to find the free body diagram of block P, right? So we're going to look at the forces that are acting on block P. The first thing we're going to identify is the force of gravity that is acting downwards, and we also have the tension, and we have the normal, and then we also have the F parallel, and another thing we have the frictional force, right? So but now in these forces, the most important forces that we need for our F net, the net force is F parallel is important, the tension, and the frictional force. So these three forces are very important in us identifying our net force, right? Let's first find the F parallel, right? So we know very well that this is the force of gravity, and then we're going to have the F perpendicular, and then this will be our F parallel, which you can also draw here. So this will be parallel to this one, meaning that this is F parallel. And remember that if this is 30 degrees, then also here it's going to be 30 degrees, right? So if we look facing this direction, then we are facing F parallel. So it's opposite. So it's going to be sine of 30 degrees is equals to F parallel divided by F of G, right? So F parallel is equals to F of G sine of 30 degrees, right? So we have found the value of F parallel. So now, because we don't know the tension and we know the frictional force, so now we can find our F net. So our F net is equals to, so we have to look at the dominant force of the system, because the system we know overall that is going upwards. So, and this is the tension, so meaning that the tension is dominant compared to these other forces here, So it's going to be tension minus the F parallel minus the frictional force is equals to MA, right? So the tension minus, so we have the F parallel, this one here, which is F of G sine of 30 degrees, minus the frictional force. We're given the frictional force here, which is 2.5. 2.5 is equals to the mass of P, it's 2 kilograms. So it's going to be 2 multiplied by the acceleration, right? So let's write it properly. So meaning that we're going to transpose this portion here to the other side of the equation. So we're going to have T is equals to 2a plus F of G sine 30 degrees plus 2.5. So this is equation 1. So if we write it properly to be clear, T is equals to 2a plus F of G sine of 30 degrees plus 2.5. So this is equation 2 for block P, right? So now that we have identified both these equations, we will be able to find the acceleration. So we're going to use this equation of block P and the one for block Q. So now we have both our equation 1 coming from block Q and equation 2 from block P. So now we can substitute one equation into another, right? So if you can see here, equation 2 is the simplest form. It's saying T is equals to 2a plus F of G sine of 30 degrees plus 2.5, right? So now we can simply substitute this equation here of T into equation 1 here, right? So let's do that. So we're going to substitute equation 2 into equation 1, right? So when we see T, we're going to put 2a plus F of G sine 30 degrees plus 2.5, right? So it's going to be minus into 2a plus F of G sine of 30 degrees plus 2.5, right? So it's equals to 3a minus 40 cos of 25 degrees plus F of G sine of 30 degrees, right? Okay, fine. So now remember that the f of g is going to be f of g is equals to mass times the gravitational acceleration, right? But now this is for the 2 kilograms. This is for block P, right? This is for block P, so it's going to be 2 multiplied by 9.8. So that's what we're going to do. I want to say minus into 2a plus 2 times 9.8 sine of 30 degrees plus 2.5. All right, plus 2.5 is equals to 3a minus 40 cos 25 degrees plus f of g sine of 30 degrees, right? So now let's add up these two here using your calculator before you multiply with this negative sign here. So meaning that we're going to have negative sign into 2a plus, so I'm going to punch my calculator, 2 times 9.8 sine of 30 plus 2.5. So I'm getting 12.3. It's going to be equals to 3a minus 40 cos of 25 degrees plus, so the f of g here, this one is for the 3a, is for block Q, right? So f of g for block Q is equal to 3 times 9.8, right? So we're going to write 3 times 9.8 sine of 30 degrees, right? So now what you can do is we'll add this portion here with this one here, right? So that's what you're going to do. So we're going to have minus into 2a plus 12.5 equals to 3a. So now let me add, so it's minus 40 cos of 25 plus 3 times 9.8 multiplied by sine of 30, right? So I'm getting minus 21.55, right? So now we can multiply the negative inside here and inside here, right? So what I'm getting is negative 2a minus 12.3. So this is 3 equals to 3a minus 21.55, right? So now let's collect the like terms, meaning that let's take this negative, this positive 3a that side, and take this minus 12.3 that side, right? To collect the like terms, so we're going to have minus 2a minus 3a is equals to minus 21.55 plus 12.3, right? So if we add minus 2a and minus 3a, we're going to get minus 5a equals to, so then this other portion, minus 21.55 plus 12.3, in my calculator, I'm going to get minus 9.25, right? Minus 9.25. And then, so let me write this section here. And then you're going to divide by 5. So you have minus 5a is equals to minus 9.25. Then divide by 5, negative 5, divide by negative 5. So your a is equals to minus 9.25 over minus 5, which a is equals to, so the final answer is giving me 1.85 meters per second squared. So this is the acceleration that is required. Thank you for listening. Please subscribe and make sure you comment down below for more videos of the channel. Goodbye.